Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Carolina Bays Failed Hypothesis. This video discusses a hypothesis for the formation of the Carolina Bays that did not work and provides a historical context of various ideas about the formation of the bays. In 1930, Fairchild aerial surveys photographed an area of about 500 square miles, 5 miles east of Darlington, South Carolina, for the Ocean Forest Company. The aerial survey did not discover the Carolina Bays, but it brought awareness to their alignment, enormous sizes, and regular shapes. A careful study of the photographic mosaic showed that the creation of the elliptical bays involved problems of extraordinary geological interest. In 1933, Melton and Shriver proposed that the Carolina Bays could be meteorite scars. They characterized the bays as having a smooth elliptical shape, parallel alignment in a southeastern direction, a peculiar rim of soil which is larger at the southeastern end, and mutual interference of outline. The authors provided a photograph illustrating intersection of bays and stated that the origin of the bays is not directly attributable to ordinary geologic processes, but that a hypothesis involving impacts by a cluster of meteorites is the most reasonable explanation. In 1942, Douglas Johnson proposed a hypothesis of complex origin where artesian springs, rising through moving groundwater and operating in part by solution, produced broad, shallow basins occupied by lakes. The sandy beaches and dunes were then formed by wave action and by wind action. In his book, Johnson illustrated an artesian spring creating and enlarging an opening. Johnson did not consider the elliptical shapes of the Carolina Bays to be significant. In 1952, Prouty published a paper that brought attention back to the intersection of bays. He reported that his statistical studies of the orientation and variation in ellipticity of the bays are most satisfactorily explained by the meteoritic theory of origin. Multiple and heart-shaped bays overlap in patterns explained most logically by the impact of tandem meteorites, some likely explosive in nature. In 1954, Charles Wythe Cook, who had a long career in the U.S. Geological Survey, published a professional paper proposing that liquids moving in a curved path react in the same way as solids, although the manifestation appears different because the particles of a liquid are able to move independently of one another. So, if the plane of rotation of a liquid is tilted, the circular orbits of the particles are distorted into ellipses. According to Cook, an eddy, like a spinning flywheel, resists any force that tends to alter the direction of the axis of rotation. The application of a force causes the axis to precess or to set its direction parallel to the axis about which it is forced to turn. The rotation of the Earth is constantly turning the axis of rotation of an eddy out of its initial direction in space. Consequently, the axis of rotation of the eddy either precesses about the horizontal east-west diameter of the eddy, or the axis becomes parallel to the axis of the Earth. In either position, the plane of rotation of the eddy is tilted and the outline of the eddy becomes elliptical. Cook made the bold statement that the proportions of the ellipse projected from a precessing eddy are such that the ratio of the shorter diameter, b, to the longer diameter, a, equals the cosine of phi, where phi is the angle of the latitude. The proportions of the ellipse corresponding to a fixed eddy are represented by the equation b over a equals the sine of phi. In 1956, Frank Melton from the School of Geology and Geophysics at the University of Oklahoma wrote a rebuttal to Cook's paper in which his principal conclusion was that the Aeolian and lacustrine gyroscopic theories that had been proposed for the formation of the Carolina Bays failed to predict the aspect ratios of the bays, their orientations, and the creation of overlapping bays. In researching Cook's claims about the eddies, Melton found that none of the elliptical basins nor any elliptical rims are found beneath the water surface at any place. Also, the elliptical bays are not present on the flood plains of modern rivers in the Carolina coastal plain, nor are they being formed by modern rivers or estuaries anywhere. So on the basis of present knowledge, the same conclusions must be applied to the floodplains of the geologic past. Melton concluded that the topographic expression of tidal eddies does not demonstrate a connection to the Carolina elliptical bays, either in origin or later history. Cook's lacustrine hypothesis had failed. It was completely wrong and nobody tried to defend it. Scientists continued trying to explain the origin of the Carolina Bays. In 1975, Ayton and Parkhurst proposed that explosions of fragments of a disintegrating comet could have formed the Carolina Bays. These researchers noted that only a comet appears to satisfy the constraints imposed both by the extraterrestrial requirements and observed terrestrial characteristics. They also pointed out that the Carolina Bays displayed radial alignment with an apparent focus in either southern Ohio or Indiana. In 1977, Raymond Kocharovsky performed the wind experiment to simulate the formation of Carolina Bays. He carved a round pool on a sand tray and then used a fan to blow over the surface of the water. He altered the direction of the wind by 180 degrees every 15 minutes for 4 hours. The shape of his initial pool was modified by the wind, but it did not produce the elliptical geometry characteristic of the bays. In 2001, Zanner and Kusila announced that Nebraska had shallow features called rainwater basins that had the same elliptical geometry but the opposite orientation of the Carolina Bays. The features were discovered using digital orthophoto quadrangles, a technology that preceded LiDAR imaging. The authors proposed that the Nebraska basins originally formed as blowouts in abandoned fluvial sands of the Platte River. By 2010, LiDAR images were readily available, and Michael Davies established a database of images that could be viewed with Google Earth. The LiDAR images made it possible to see detailed features of the Carolina Bays and the Nebraska rainwater basins without interference of vegetation. This image 25 kilometers southwest of Fayetteville, North Carolina, is completely covered with bays. In 2010, Davies and Gilbride used great circle trajectories adjusted for the Coriolis effect to calculate the convergence point of the Carolina Bays and Nebraska rainwater basins at Saginaw Bay in Michigan. The convergence point indicates the location where an asteroid or comet impacted the Earth. The fact that there is no recognizable crater in Saginaw Bay suggests that the terrain was covered with a layer of ice that protected the surface and prevented the formation of a typical extraterrestrial impact crater. In 2017, the glacier ice impact hypothesis proposed that the elliptical geometry of the Carolina Bays and the Nebraska rainwater basins corresponds to conic sections that originated as inclined conical cavities from secondary impacts of glacier ice ejected by an extraterrestrial impact on the Laurentide ice sheet. Impact experiments demonstrate the creation of inclined conical cavities on viscous ground and the transformation of the conical cavities into shallow depressions by viscous relaxation. If the Carolina Bays were caused by a saturation bombardment of large chunks of glacier ice, then the origin of the bays may be associated with the Younger Dryas extinction event, which resulted in the disappearance of the North American megafauna and the end of the Clovis culture 12,900 years ago. Currently, there is not enough evidence to draw a definitive conclusion, but we can be sure that the debate about the origin of the Carolina Bays will continue for a long time. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.